All right, welcome back. Now in this tutorial, we're going to have a hands-on of what is referred to as transfer learning. So previously we've gotten to understand what transfer learning is. So we got an idea of what it is. Okay, so in this particular tutorial, we're also going to see how it is being implemented. Okay, we're going to use the VGG16 as a use case and then try to implement that using the concept of transfer learning. Okay, so ideally you need to build your own architecture right from the scratch, but the previous session made us know that you can actually use what people have already built and then stand on that one and make yours your model more robust and have a high performance. All right, so if that's what you're going to do over here, I'm going to use the VGGNet, which has already been built years back, and it's quite robust. It was actually built on ImageNet dataset, which is the largest dataset that we have so far. Okay, so if it has learned from that dataset, then it is really robust for our use case. So in this case, what I'm going to do over here is that I'm going to load this dataset. So ideally, you're supposed to have your problem statement or your use case will have some sort of a dataset, but it might be small to train a robust CNN model. Okay. So that's why we want to use a pre-trained model, and then based on that one, we can actually customize it to our use case. Okay, that's what we are trying to do over here, right? So in this case, my data set is it's a data set that I'm getting from TensorFlow. Okay, so TensorFlow underscore dataset is having a data set over there, right? So I'm just importing and then just storing it in just shorten it to TFDS. Okay, TensorFlow dataset. All right, so that's what I'm doing over here. I'm just loading that particular dataset, okay, which is TF underscore flowers. It's just consists of flowers over there, right? And then I do train test split over here for 70% for training and 30% for testing. All right, that's what I'm doing with my batch size of 1, right? And then as supervised equals true, right? So that I'll include the labels for the test. Okay. All right, so when I do that, I'm going to have my train data and then my test data respectively. All right, then I do the normal thing, I rescale them, right? So in this case, I'm rescaling or resizing it to 150 by 150. Okay, and I do the categorical. Okay, I do categorical over here, right? So that my labels will be categorical, right? And I can use categorical cross entropy to be able to get those categories in my labels. All right, so that's what I'm doing now. Once I have my data set ready, I will not like to build the entire model on this data set that I have. Okay, I will not want to build the entire model on this small data set that I have. So I'm going to use VGG, right, which has already been built on a very large data set. Okay, so in Keras, right, if we go to Keras applications, you will see quite a lot of pre-trained models that you can use. Okay, so here I'm going to use the VGG16, right? You can use any of these ones that are here, right? But here I'm going to use the VGG16. Okay, so that's basically what you see over here that I'm using. You see that I'm doing TensorFlow keras.applications.vgg16. Okay, then I'm importing VGG16. And once I do that, I also import preprocess, right? So that I'll be able to preprocess whatever is there, right? So once you do that, you can just do VGG16, and then I'm going to load the weights. Okay, I'm going to load the weight that they have trained on ImageNet. Okay, that's what I'm going to do. And if you see here, this is quite important. You see that I'm doing include underscore top equals false, right? Because what I want to do is that I want to maintain all the weight, okay, and then only train the fully connected area or layer to suit my own use case. Okay, in VGG16, right, the last layer is having 1,000 classes because the ImageNet dataset have 1,000 classes over there. But in my case, my classes are just 5. Okay, if you see up here, right, my number of classes are just 5, so I cannot use that 1,000 classes. So that's why I'm setting include top equals false, so that the top layer, which is the fully connected layer, will not be included when I'm loading this VGG. Okay, so it's something like this. I'm loading everything. Okay, this is the VGG architecture. Okay, so I'm loading everything, right? All the convolutional layer, right? I'm just loading all of them, right? And then I'm saying include top. This is the top part, which is the fully connected area. Include top, right, equals false, so, which means that I will not load this one, but I will just load this one. Then I'm going to build this part for my own use case. Okay, so that instead of the 1,000 classes, I will just build it for only 5 classes. Okay, so that's why over here I'm setting include top equals false. Okay, and then I do the input shape, right? Here too you can see that base model dot trainable equals false, which means that I'm not going to train this part, the convolutional layer. I'm not going to train it. Okay, the convolutional and the pooling layer, I'm not going to train it. So that's why I'm setting the the trainable equals false over here, right? And then I do the pre-processing. Right now, if you see the model dot summary over here, right, you can see that this is the VGG architecture, right? You have the input the input layer, which has 150 by 150 and then by 3. There's since it's a colored image, you're gonna have 3 channels over there, right? And the size is 150 by 150. Okay, and then you see that it follows by convolution, right? 2 convolution, 1 pooling, 2 convolution, 1 pooling, 3 convolution, 1 pooling, 3 convolution, 1 pooling, right? Just like that. And then another 3 convolution, 1 pooling. That's what it is, right? 2 convolution, 1 pooling, 2 convolution, 1 pooling, 3 convolution, 1 pooling, 3 convolution, 1 pooling, 3 convolution, 1 pooling. That's how it is. Okay, so you can see that's how the architecture over here looks like. All right. Okay, now once I do that, if you come down here, right, you can see that we have total parameters to be this 14 million. Okay, 14 million parameters, right? And if you come here, you can see that trainable parameters equals 0 because I'm not training anything there, right? Unlike the others that we saw earlier on, you will see that the total parameters and the trainable parameters were the same, right? And then non-trainable parameters were 0. But in this case, I'm not going to train anything here. So you can see trainable parameters equals 0, right? And then non-trainable parameters will be the same as the total parameters, okay? Because I'm not training them. All right, now once we do that, now we can now build the top part, okay? The top part, which is the fully connected part that we did not import, okay? So here I'm doing the normal thing, right? I'm importing the layers and the model, right? And then what I'm going to do is I'm going to flatten whatever is going to come in from the VGG16 that I've loaded. Okay, then I'm specifying here that layers.dense. I'm just creating my fully connected layer. Okay, so 15 neurons activation equals ReLU, 20 neurons activation equals ReLU, and then the last layer, which is going to be for the prediction, right? I have 5 classes over the activation and softmax. All right, so once I do that, I just create my sequential over there, then I put all of them in. Okay, we could have also done them over here, just do sequential over here, right? You could have also do maybe model equals, then maybe we do our normal sequential thing, right? We do our normal sequential like that. Okay, and then here we do model.dense and blah blah blah, then that's it, right? But here I did not do that. I'm just saving it. Okay, I'm just saving them in a variable. Okay, then here I can just come and put them in. It's just the same thing but different strategies of doing it. Okay, so I do models.sequential, then here I first put in my base model, okay, which is the VGG that I loaded. Okay, that's the base model. The VGG that I've loaded is the base model, right? After that, it follows the the flatten. Okay, whatever is going to come out from here, I'm going to flatten it, and then the dense layers will come. First dense layer, second dense layer, and the predicted prediction layer will come. That's the final layer. Okay, so now the architecture is now complete. I have all the convolutional layer from VGG16, and then I've trained the fully connected area. Okay, I've trained the fully connected layer. That's it. Now once that is done, the rest is just the normal thing that you do. You compile and then you fit. Okay, that's it. You are done. So the only thing that you need to know over here is what you're going to load and what you're not going to load. Okay, whether you want some parameters to be trainable, right? You can also specify. So if your data set is a bit medium size, then you can maybe train some part of the weight, right? But if your data set is small, you just set trainable equals false, and also include top equals false to customize it to your own situation. So over here I just run it for let me see, I just run it for 20 epochs, right? This is a huge weight that we have loaded. Ideally we should run it for not less than 50 or 100, right? 100 epochs to get a better accuracy, but this one I just run it for I just run it for 20. Okay, so you can see the accuracy for training is 91, accuracy for validation is 66. Okay, so if you run it for more, we will get a better a very good accuracy over there, right? And this one is even going to take you quite a lot of time. Okay, can take you half an hour or even an hour depending on the capacity of your laptop or your system, right? All right, so after here, you can just use your model to do whatever that you want to do, whether prediction or you want to save it for later use. You can just do it that. Okay, you can do that. The idea is how to load and then customize the last part to suit your own use case. All right, so I hope now you have an understanding of how we do the transfer learning. Okay, so choose a different use case. As I said, if you go to Keras, there are a lot of these base models over there, right? You can just go to the documentation over there, right? And you can just see. If I let me even add this one here for you so that you can let me put it over here, right? If you want the link to go there, right, you can easily go to that link and then you can easily get to see which base models are there which you can use. Okay, and then you can just use it for your own use case, right? As we progress, we're going to see more of these things over there. You realize that most of the things that we do, we don't actually build them from scratch. We use the base models and then we base on that one to build more robust one. Okay, so that is transfer learning for you, and I hope you've gotten an idea of how it is done. All right, keep practicing and you become good at it. All right, so see you in the next tutorial. Have a nice day.